to the Light It Up podcast. On today's episode, Tom sits down with John Moody. John is the Director of Technical Products for Hinkley Lighting, based out of Cleveland, Ohio. Today's podcast will encompass one of John's product specialties, which is everything ceiling fans, and how that ties back to LED lighting. I'll let Tom pick it up from here.
John, I'd just like to welcome you to the Light It Up podcast. This is a neutral-based podcast that's more or less for information only on latest technologies of LEDs and, just everything that has to do with lighting and ceiling fans and stuff like that. So I kind of look at you as the godfather of ceiling fans. You've put more people on the map for ceiling fans and done a great job with it. So I'd just like to welcome you to the podcast and tell us something about yourself.
Well, thank you, Tom. I'm glad to be here. And there are, quite a few folks, not quite a few, there are several folks that would fit into that category of being in the fan business for quite some time. But I feel that I'm very fortunate the way I ended up here. I began back in the late 80s as basically an engineering services person, basically a draftsman, and through the years worked my way up, went back to school in the evenings, got a Bachelor of Science in Engineering, and then as I morphed more from the engineering to the product management side of things, I really found a serious interest in how business itself was run. So I went back to school and got a master's in business. And so I've been very fortunate that I came up through the engineering ranks from the very bottom. And then I morphed in from engineering to the business side of it. And here we are today. I'm at Hinkley and in charge of the ceiling fan segment of the business. So I've been very fortunate, as I said.
So when you said it was about the late 80s or so when you got into the lighting industry, who was that with?
I began my career at Emerson Electric in St. Louis. And the first part of my career, I was fortunate to work in a variety of products. I worked in power tools and the big wet dry vacs and hand tools and console whole house humidifiers. And then the mid-90s is when I first ventured into the ceiling fan division. So I got into the ceiling fans in mid-90s.
I see. Okay. So what is your current position at Hinkley?
I am director of fan product for Hinkley. So basically in charge of product management and profit and loss somewhat, and it's a great team here at Hinkley, so we work together and do a great job to make sure that the category is moved in the direction that it needs to be.
Sure. So getting into some of the technical or just some of the changes that have happened within the last 20 years of ceiling fans, what do you see as some of the biggest changes here recently?
Yeah, there's been a lot of changes in ceiling fans the last 20 to 30 years. Obviously, the change in style. 30 years ago, all ceiling fans were basically either polished brass or appliance white, basic 5-bladed pull chain fans. Then they kind of morphed into the more decorative product, which is kind of where we're at now in terms of style. Everybody's coming out with more decorative and more style-oriented ceiling fans. Some other areas would be some technical upgrades and controls. Back then, everything was pull chain, and then we moved into remote controls with RF technology. And then the last 4 or 5 years, it's kind of going into the smart home technology with the IoT aspect of fan controls. So controls have made some changes as well. Motors would be another technological advance over the last 15 or so years in ceiling fans. Originally, all motors were AC motors, and we eventually morphed into using DC motors, which have a lot of advantages for the end user.
What would be some of those advantages? Because there's quite there's quite a cost difference. If you have two fans, the only thing that's different is AC versus DC motor. There's quite a cost difference between the two, isn't there?
Yeah, DC motors differ from AC motors in that the electromagnetics of the internal motors is controlled by electronics that are in the fan's receiver or electronic package. So there's some added cost there in the electronics to control the motor. There's also an earth magnet inside the DC motor, so that's a little bit more cost. So there is a cost adder to a DC motor, but DC motors consume up to 70% less energy than an AC motor, and DC motors are virtually silent, or AC motors sometimes, if they are not configured properly internally, sometimes you'll hear a motor hum or a wah 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 noise from an AC motor, which you will not hear from a DC motor. DC motors run a lot cooler as well, so the longevity or the lifetime of a DC motor should be greater than an AC motor, just because there's not as much heat generated on a normal basis.
Sure, and plus if you're using a ceiling fan to cool off a room, you don't want another device that's adding additional heat. So,
right.
It's funny. I have a couple of DC fans in my own home, and I notice that when we go to start it up, they just don't start in one direction. It's like it calibrates itself or tunes itself back and forth before it. Is that pretty typical of DC motors?
Yeah, the old AC motors, when you pull the chain to turn them on, basically the current just rushes through the windings and it creates the electromagnetic field, and that generates the torque. Where a DC motor, you turn it on, and as I said, all of the electromagnetic timing is done by electronics. So the electronics need to figure out where basically the starting point or ground zero is of the timing. So it kind of rocks back and forth to say, okay, this is where the first pole is or whatever. And then from then on, it can control the timing properly to get your speeds and your timing correctly in your ceiling fan. Right.
So that's an important point for, our listeners. Sometimes, they'll hook up a ceiling fan and, what's this rocking thing going on? But that's very, very typical, and it's supposed to do that. So we're good to go. Right. What about regulatory challenges? I know that, going back to the ALA back in like 2005, was it state of California, and then it was adopted by, I think, the Energy Department for wattage limiting devices on ceiling fans. Was that the beginning of it?
Yeah, I don't remember if it was the state of California that started it, but in terms of the federal guidelines, the Energy Policy and Conservation Act of 2005 is where regulations, I believe, first got put in place that were telling ceiling fan manufacturers that you needed to limit your light kit wattage to 190 watts. Well, the problem at the time was there was no device that we could readily put into our products to limit to 190 watts. So it took a while to develop that. And then since then, there's been a couple of additional iterations or upgrades to the EPAC law of 2005. I think they updated every 7 years. But since then, the 190 watt limiter has been eliminated from a requirement to the product, and now they just limit the wattage. And wattage in itself is kind of limited anyway, because other laws regulating light bulbs in general have sort of limited the available light bulbs that someone could put into a ceiling fan. So
that's just one less component now that you're putting into the ceiling fan. Is that wattage limiting device? You don't have to put that in anymore, correct?
Yes, that is correct.
Okay. So, and I know that some of the challenges that you have with all the different electronics is sometimes those wattage limiting devices were playing a little havoc with all the other electronics in with those ceiling fans. So plus, the additional cost, that's it's a good thing that they got rid of those. So then another big thing that came up was the whole CFM measurement requirements. What's the history behind that, and where are we at with that now?
Yeah, again, the CFM, which is cubic feet per minute measurements for airflow, have went through a couple of upgrades or iterations with the EPAC law as well. And prior to the EPAC law, everybody would kind of do their own airflow testing with their own methods, and they would publish that information, and there was no relevance to it compared to manufacturers. So, the one thing good about EPAC stepping in and setting regulations is now everybody's testing to the same standards, everybody's publishing their airflow in the same required manner, so that a end consumer can truly look at the information and determine the performance of a fan. But the testing of CFMs is really quite complex, more so than what most people would probably think. I mean, the room has to be a certain size, the wall material, floor and ceiling material have to be a certain type, the sensors have to be a certain type, have to have a certain tolerance, they have to be in certain locations, and there's software that goes along with it. And so it's quite a complicated process. So we can't just hang a fan up in our back storage room back here and put a handheld meter under it.
From what I remember, for a long time, there were only like a couple of these rooms available in the entire United States to test all these fans, right?
Yeah, and they still need to be tested by a certified third-party lab, which most UL and ETL labs are. And then there are a number of the ceiling fan manufacturers that have invested in the equipment and the rooms in their factories to get their labs certified as well. So there are several avenues to get it tested now.
Right. Just for everybody's clarification, what does the acronym EPAC stand for?
It's the Energy Policy and Conservation Act.
And that's a federal thing?
That is a federal law that was passed by Congress, I believe. 2005 is when it began affecting fans, but I believe it may have been a law that was actually earlier than that. I'm not sure. I'd have to look that up. But anyway, it's the Energy Policy and Conservation Act.
Do the CFMs have to be reported on all different speeds?
CFMs need to be reported on. What they use is there's a formula where they take the high speed performance and the low speed performance, and the formula spits out a weighted average number. So the weighted average number and the high speed number, I believe, is what we need to report to the Department of Energy. And all of our cartons, instruction manuals, printed materials, websites are all supposed to have the weighted average information published as required by the Department of Energy.
So it's the weighted average. It's not the highest point, correct?
Correct. And in my opinion, I don't think that was the best approach, because then people are taking low speed and they're moving low speed up and up and up, so the average number's higher. Well, most people in their ceiling fans want low speed to be, a decorative, comfortable speed where it's slowly stirring the air in a room, but not necessarily creating a huge wind chill effect. Where that in a lot of cases, that's kind of went away now with the way they've set the weighted average system up.
Huh. I didn't know that. So how do they determine, when you have all these different electronic dimmers and the remote controls and the Lutron casetas and some of the Lutron. How do they know which one to use, or how does that work?
In terms of dimming the LED light kits, there's a lot of companies use a lot of different electronic methods. And so what most ceiling fan manufacturers say is, we recommend using the control that comes with or is recommended for your fan. Having said that, there's probably a lot of other controls out on the market that would work with a ceiling fan LED light kit. But like I said, there's so many iterations and variations of how companies dim LEDs that, we can't safely say that, you can just use any dimmer control out there.
But some of the dimmer controls, the wall-mounted dimmer controls, they'll have one for the light kit and then one for the fan itself, correct?
Correct. Usually in ceiling fan controls, the light kit circuit is a separate circuit in and of itself, separate from the fan side of the control, even though they're in the same black box that goes in your ceiling.
Right. Okay. So I'm just trying to when you when you regulate the fan speed on a ceiling fan, are there several set levels, or is it kind of an infinite amount, kind of like a light bulb?
On ceiling fan motors, for AC motors, it's generally been 3 speeds for ever and ever. You have pull chain and you have high, medium, low, and off. And then when we went to DC motors, for whatever reason, I'm not sure the reason, but DC motors came out with 6-speed controls. So DC motors in general have always been 6-speed controls. And then recently there have been some 4-speed DC motors. So,
taking notes on that. Maybe that can help solve some of my issues at home. Okay. Do ceiling fan remotes and receivers dim differently than regular wall dimmers?
Well, a lot of wall dimmers are just, in the ceiling fan world anyway, a lot of wall dimmers are still RF controls. So they're talking to the same dimming circuitry that's in the receiver that your remote would be talking to. But if it's a hardwired control, I'm not sure. I would have to, like I said, there's different varieties and versions. And
right. Okay. Is the power to a light kit affected by the motor on the ceiling fan? And I guess what I'm looking at is, over the past 25 years, if somebody had a 25-year-old ceiling fan and then and it had a light kit and then they put LED lamps in it, is the older technology of motors and the way that things were wired, could that possibly affect the way that LEDs function on that ceiling fan light kit?
Yes, when ceiling fans first hit the market when LED light kits first hit the market in ceiling fans, there were a lot of upgrades needed to make to our control circuitry in our controls to better address like flickering when it's dimmed down low so it don't flicker.
Right.
Sometimes they wouldn't shut off all the way. So there were some electronic upgrades that needed to happen in fan controls when we moved into LED light sources.
I got it. I'm just going to jump back real quick to the CFM thing, because I thought I remember reading somewhere that if you had a strictly decorative type of ceiling fan, that you didn't need to report the CFM of those fans. Is that correct?
That's correct. There are certain requirements, certain regulations that if your ceiling fan fits into that small set of requirements, then it could be considered a decorative fan and not need to be tested and reported. And I don't remember off the top of my head what those requirements are now, but I think RPMs had to be below 45 or something. And basically it was ceiling fans that are strictly for visual purposes and not airflow purposes.
Right. Like the ones that had like the paddle fans that maybe had a bank of 4 or 6 of them that you just see the paddles swaying back and forth. I mean, they're not doing anything other than looking nice. You know, I've been in those rooms and you could barely feel anything. So something like that, you know, probably doesn't need to meet any of those types of requirements, correct?
Correct, but they are an outstanding aesthetic piece if in the right setting. But yeah, they don't move a whole lot of air, and therefore they're not required to be tested.
Right. So I'm going to jump back into some of the regulation. Are there any Title 20 or Title 24 requirements of ceiling fans?
Well, ceiling fans, since they are included in the EPACT law and EPACT requirements for how the wattage is limited, the requirements are set in the EPACT law. So federal law trumps any state law. So technically, ceiling fans do not need to register under Title 20 or Title 24 because they are covered under the federal law. I don't know if that makes sense, but
yeah.
I mean, most people do still test to the Title 24 requirements with their lighting sources, and you can advertise that meets Title 24 requirements, but being a requirement to certify under Title 24, that's just not the case with ceiling fans because of the covered under the federal law.
So California never came out with a Title 24 requirement of ceiling fans, correct?
Correct.
Okay.
Technically, ceiling fans are an appliance. So if there wasn't a federal law, they would fall under Title 20 instead of Title 24.
Gotcha. Okay. So what I've seen, ceiling fans have done about the best job of all lighting products to switch from a drop-in type to an integrated. Is that pretty much what you see as well?
Yeah, ceiling fans, different from lighting, where a lot of the lighting, the lamps are out in the open or part of the decorative aspect of a fixture, where ceiling fans, there's a lot less real estate to house your light source. So trying to keep the small overall envelope of a ceiling fan sort of drove ceiling fan development to use more of the LED platforms and light kits, which are a lot more low profile than trying to get a bulb or two or a lamp or two inside of a piece of glass. There are still lamps used in some light kits that, are the older style with bulbs or with bowls where there's, actually room for a lamp.
Sure. Is there a big cost difference between an integrated light kit and a bulb light kit if it included the lamps?
Not really. I mean, it's comparable. I mean, depends on how many lamps you have and so forth. There's not a huge difference. And part of the EPACT law was if you do have sockets for lamps, you have to supply the lamps and the carton with the ceiling fan. That's another part of the EPACT law as well.
Right. So what about color temperature? With us, 2,700, 3,000, some areas 4,000. What about ceiling fans? Do the ceiling fan manufacturers make those integrated modules available, or how do they handle that?
Well, different manufacturers handle it differently. I mean, there are a lot of platforms out there now where you can, by toggling a switch on the board itself, you can switch between 2700 and 3000 or maybe even 5000. I think most of the light sources out there now are 3000K, because I think everybody kind of determined that's what produced the best light for, what we were trying to do with a ceiling fan light. But yeah, there's different color temperature platforms you can use, and again, there are some that have a toggle on there. As I said, you can adjust, and there's also some people that are using what's called warm dimming, where when it's at full intensity, it's a higher color temperature, and as you dim it down, it sort of gets to a warmer color temperature. But yeah, there's a few different avenues that are being worked on now for ceiling fan light kits.
Plus, I would think with ceiling fans in general, unlike lighting products, ceiling fans, they're basically, a few different sizes, and, all the motor sizes are probably, if I were to guess, 3 or 4 different motor sizes, so that you can design the integrated board. You don't have that many different integrated boards like you would in a light fixture. Is that correct?
Yeah, correct. There's probably 2, maybe 3 different sizes you would need to cover the vast majority of ceiling fan designs. So it's, once you get one developed and tested and proven that you feel comfortable using, then it's, you only have to keep 2 or 3 platforms at arm's reach that you want to put into your product.
Right. And I take it those integrated packages, lighting packages, are they replaceable?
Correct. They just plug into lead wires with usually it's a 2-pin quick connect situation. So if one ever would fail, which doesn't happen nearly as often as lamps used to, but if one ever does fail, you just remove 2 or 3 screws and unplug it and plug the new one in and screw it back in there and put the glass on. You're good to go.
Pretty easy.
Right.
Pretty easy. Huh. So what customer or contractor issues come up continuously regarding ceiling fans?
I think the biggest issues we hear about are a couple of them. One of them would be the reliability of electronics and controls, which has kind of been close to the top of the list for as long as I've been in ceiling fans, just because electronics in their general nature don't last as long as an LED bulb or a motor. The second would be the integrity of finishes on ceiling fans in a coastal area. If you live in a coastal area and you have the salty mist all the time, it really wears and tears on finishes of ceiling fans. And then I think the third aspect would be airflow. Everybody wants more airflow. It could be 12,000 CFMs and somebody would want 13,000. So I guess that's kind of the three main aspects I could point out.
Right. I can remember we live obviously in a coastal area and where the humidity is about as high as the temperature. And you see a house that may be 5 years old or so, that these fan blades are like sagging, 6 inches or something like that. If somebody walked close to them, it looks like they'd get their head lopped off. What causes the blades to droop like that?
Well, most coastal area ceiling fan blades are made out of ABS plastic, and if it's a lower cost fan, those plastic blades are probably thinner than what would be recommended for a highly intense sun area or coastal area. So as with any plastic part that's long and sticking out in the sun, it's probably taking a beating and sort of warping as it cycles through the hot and cold seasons.
Well, the ceiling fan blades, you said they're made out of ABS. Prior to them being injection molded, what were they made out of?
Well, most fan blades are either plywood or MSD, which is sort of particle board. But outdoor ceiling fans, I think as long as I can remember, they've always been some type of plastic material.
What's the biggest difference between a damp rated ceiling fan that you can use under a porch or whatever and a dry location only?
Usually damp rated fans, the finish of the metal components on the fan are usually galvanized before they're finished or lacquer coated, so they withstand elements a little more than an indoor fan would need to. And the hardware is usually stainless steel, should be stainless steel. So that's the two major components that sort of help a fan that's on a covered porch or in a semi-protected area withstand the elements.
Now, are there wet location fans that can just take the pouring down rain?
Yeah, any fan that is wet rated, you're able to spray it off with a garden hose, or it can be out if you want it hanging on a tree limb. They are designed to be in direct contact with the elements. And a lot of the outdoor ceiling fans the housings are all either aluminum or plastic themselves. So there are a lot of models out there that are truly built to withstand the elements as much as a ceiling fan can. But yeah, a wet rated fan is built to be in direct contact with the elements.
Are there wet located fans with light kits?
Yes, there are wet located fans with light kits. Obviously, the light kits are sealed so that water does not get into them. But yes, there are a variety of light kit models out there that do have integrated light kits in them for wet rated situations.
Right. And, wrapping up here, what do you think the most frequent customer service call that you get regarding ceiling fans, or that your customer service department gets regarding ceiling fans?
There's a couple things. I think the first one would be probably replacement controls, or somebody had a lightning storm move through their area, which happens a lot in the Midwest and the lower Midwest. So they need new controls to replace the electronics from, a voltage spike or something. And then the second one, it doesn't happen nearly as often, but I think over the years there's been a lot of calls for outdoor fans where people left their fan blades on during a storm or something, and it threw their fan up into the ceiling with high winds, and blade arms broke. So blade arm sets.
Huh. I would imagine one of them has to be, I've got two ceiling fans in separate rooms, and, I have two remotes, and I want them to work independent of each other. And coming from the factory, they're not like that. I turn on the remote for the living room, and the one in the bedroom goes on. That's got to be a pretty common occurrence as well.
Yeah, it is. Getting controls cross-programmed and then having to reset one of them and programming it to the correct control, that's a pretty common call as well. You're correct.
Huh. Well, John, I think we've about covered everything that I wanted to go over here. Just probably at a low level from a ceiling fan standpoint. Anything from you of things that you'd want our listeners to know? Any problem areas, things to look out for, or anything like that regarding ceiling fans?
No, I think the one thing I would try to stress is, I think ceiling fans provide a calming and a comfortable situation for people that use them. And I think there's a lot of people that aren't familiar with ceiling fans or don't use ceiling fans. One of the things that worries me now is a lot of builders aren't even putting boxes in the center of ceilings in a lot of rooms in new homes. So I think anything we can do to help people understand the value of a ceiling fan. I mean, I'm kind of biased, but I got a fan in about every room in my house, and we use them all the time. But I think there just needs to be more of a push to the advantage of a ceiling fan. It provides comfort, it saves energy in your heating and air conditioning, and they provide a decorative element to your house as well. So,
yeah, you know what? You bring up a good point, and this spark up another question here. So, geographically speaking, where are the most ceiling fans sold, and where are the least?
Well, the most are sold in what we generally refer to as the Smile Belt, which is kind of California down through Arizona and Texas and Florida, Georgia, the Carolinas. Sort of that area is kind of the largest volume. But there are a lot of fans sold in New England, or a lot of fans sold in the Midwest. I think the slowest area would probably be the northern plain states, but there are still fans sold there. So, but the coastal areas would be the highest volume areas, obviously. Right.
Yeah. I, like you, we have a ceiling fan in just about every room, and if somebody's in that room, it's always on. So it makes the world a difference, whether it's in the the high temperatures of the summer, or even in the winter. It makes a big difference.
Right.
So, well, John, I want to thank you for taking your time here today. I know amongst all the craziness with this virus going on and everything, it's pretty tough to get away and to give a few minutes. But like I said, I appreciate you taking the time today and discussing things about ceiling fans. And I welcome any listeners that have any questions about ceiling fans to reach out to us and send us an email, and we'd be happy to answer it. So, John, thanks. Have a great day, and stay safe.
Yeah, thanks for having me, Tom. It's always a pleasure to talk about one of my favorite topics. So, thanks for having me, and it was quite enjoyable. And thank you very much.
All right, John. Have a good day. We'll see you later.
You too.